4:55. Chris is enjoying a day at the Splasharama water park. His demand function for sliding down El Monstro water slide is given by d of x 0.425 x squared minus 5.7x plus 22.5. Where x is the number of slides and p is the price in dollars. Number of slides. Fine. And of course this is the p, or demand of x. Where x is the number of slides and p is the price in dollars per slide that he is willing to pay. Find Chris's consumer surplus if he buys 3 slides. So if x equals 3, I have to find p, or d of 3. That's my first concern. 0.425 multiplied by 9 minus 5.7 multiplied by 3. I'm making sure that I entered it correctly. And then plus 22.5. And this is 9.225. Okay. If he buys 3 slides, then we know that he will pay multiply by 3. So 27.675. Okay, so now consumer surplus will be the integral from 0 to 3 from the demand function 0.425 x squared minus 5.7x plus 22.5 dx minus 27.675. That's the area of the rectangle. He buys 3. Each of them will cost 9.227. So I'm thinking for a second. So the price for 3 is that, and that's the area. Very good. We have that, and now we have to continue. Number 9. Okay, here it is. 0.425 x to the third over 3 minus 5.7 x squared over 2 plus 22.5x from 0 to 3 minus 27.675. That is the area of the rectangle. So this is the point. The point is 3, comma 9.225. And the area is 3 times 9.225. This. Okay. So next. Luckily, I only have to plug in 3, not 0, because when I plug in 0, everything is 0. So 27 divided by 3 is 9, so 0.425 times 9 minus 5.7 times 9 divided by 2 plus 22.5 times 3 minus 27.675. Okay. 0.425 times 9 minus 5.7 times 4.5, because this is 4.5, plus 22.5 times 3. I'm checking all my numbers just to make sure. Yes, minus 27.675, enter, $18. So what is 18? So he is paying 27.675, but he's getting the fun or whatever other surplus activities or whatever he's getting extra in the value of $18. Okay, part B. Suppose now that the supply function is given by S of x. Okay, let's see. 0.3x plus 5.3. Find the producer surplus if Chris is sold 3 slides. Okay, so then the consumer surplus is that 27.675 minus the integral from 0 to 3 from this function, dx, which is 0.3x plus 5.3. So let's see what they are getting. 0.3x squared over 2 plus 5.3x from 0 to 3. Luckily, again, I only have to plug in 3. 27.675 minus 0.3 times 9 over 2. Remember to distribute this. Minus 5.3 times 3. 27.675 minus 0.3 times 4.5 minus 5.3 times 3. 27 minus 4, yep. So this is $10.425. What does that mean? They are selling him this at this price, but they should sell it at 17.675 because they are selling us 3 rides for 27.675, but we should only pay 27.675 minus this. We should only pay 17 point blah blah blah. Find the equilibrium point and the consumer and producer surpluses at that point. Assume that Chris buys no more than 6 slides. Okay, so let's determine just the equilibrium point. And because we have to just simply redo everything for that equilibrium point. But let's just determine the equilibrium point. Is that okay?
Yes.
Okay. So the functions are, the supply is 0.3x plus 5.3. And the 0.425x squared minus 5.7x and plus 22.5. Okay, so I have to move this term and I have to move this term. So 0.425x squared minus 6x, negative 5.7 minus 0.3 is negative 6x, plus 22.5 minus 5.3, I think it's a 17.2. Ugly equation, I have no choice. Am I correct here? Yes. Yes, I am correct. So I have no choice but use the quadratic formula and find x. So x equals negative b plus or minus b squared minus 4 times a times c divided by 2a. Ugly. Very good. So left parenthesis, here's how I put it in directly. 6 plus the square root, parentheses, 36 minus 4 times 0.425 times 17.2, close the parenthesis, close the outside parenthesis, and divide by, in parentheses again, 2 multiplied by 0.425. And then I repeat, changing this symbol to minus, overriding it right here. So I got 1x is 10.1176 and the other one is 4. They are telling us in the problem, assume that Chris buys no more than 6 slides. This algebraically is correct, but is more than 6. So it cannot be considered. So the only thing, the only equilibrium point will be x equals 4, and I have to find the y value. 0.3 times 4 is 1.2 plus 5.3, 6.5. And that would be the area of the rectangle, 4 times 6.5. Any questions? Any questions? Do we get the idea about the consumer surplus and consumer and the producer surplus? And how to calculate them, how to set up the integrals? Okay, so the last section that we cover from chapter 7 deals with differential equations. I will not be able to finish. I know I'm looking at the time. I know I have only 7 minutes left, but at least I will start with a couple of simple applications. What is a differential equation? It's an equation that has derivatives in it. Something like y double prime minus 2y plus 3y prime equals 14. This is an example of a differential equation. It has the derivative, it has the function, it has the second derivative, it has the first derivative, and the function. They don't have to all be in there. I just give an example in which we had the function and the derivative and the second derivative. This is an example of a differential equation. There are many types of differential equations, and I would like to just start with an example on page 509. And let's say problem 9. At this point we're not solving because I don't have the time in 7 minutes to show you how to solve, or 5 minutes now already, but I have an example or two if you'd like. Show that y equals e to the x plus 3x e to the x. Show that this is a solution of the equation, the differential equation, y double prime minus 2y prime plus y equals 0. So in this problem, they're not asking us to solve. I have not gotten to that yet. I did not show you how to solve a differential equation. But the problem is only asking us to show that this is one of the solutions of this equation. What am I going to do? Any suggestions? Any ideas? What do you think we're going to do?
You plug in for y?
Yes, absolutely. This will be replaced by e to the x plus 3x e to the x. Perfect. What do I...
First derivative?
Of course.
You plug that in as well?
Exactly. Y prime would be, careful because this is a product. So e to the x prime will be e to the x plus 3, leave the 3 outside. The first function prime is 1 times e to the x plus x times the second function prime, which happens to be e to the x. I will simplify it. E to the x plus 3 e to the x is 4 e to the x plus 3 x e to the x. So this will be replaced by this. We have one more piece to work on. How do I get this piece? Of course, makes sense. So let's find the second derivative. Again, this is a product, careful. 4e to the x is 4e to the x prime is 4e to the x plus, leave 3 outside. Again, the first function, I differentiate the same thing. I can copy it from here. E to the x plus x e to the x. I further simplify. 4e to the x plus 3e to the x will be 7e to the x plus 3xe to the x. So now I have all pieces. I'm going to put this and here multiply by -2 and then plus the function, and I'm going to see or show that this equals 0. If it does not, then I'll come back and maybe I have an error. Assuming I don't, I'll say no, 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 no. This is not a solution of this differential equation. But if I do get 0, plugging in the second derivative, the -2, the first plus the function, then I will say yes. Yeah, this is one of the solutions. May not be the only one, but it's one of them. Great job. So 11, so second derivative, 7e to the x plus 3xe to the x minus 2 in parentheses, the first derivative, 4e to the x plus 3xe to the x plus the original function, e to the x plus 3xe to the x. And now, after I simplify everything, if I get 0, I'll say yes. If I don't get 0, I may have to go back and check my work, because they say show. So it's not.
I had a question.
Yes.
What you wrote as like y double prime minus 2y prime plus y equals 0. Is that a general equation, or is that specific to this problem?
It's specific to the differential equation given to us.
Okay.
The second derivative minus 2 times the first derivative plus the original function.
Okay.
If this were 3 or 4 here, or -10, or then I would have followed the pattern they gave us, the equation, the differential equation they gave us. But this is what they gave us for problem 9. Very good question. Is this okay?
Yeah.
Perfect. Okay, so now let's see. So I'll continue. 7e to the x plus 3xe to the x minus 8 e to the x minus 6xe to the x plus e to the x plus 3xe to the x. So 7e to the x minus 8e to the x plus e to the x, are they going away? Yes?
Yes.
3xe to the x minus 6xe to the x plus 3xe to the x, are they going away? So the answer is, and that's exactly what we had here. And then I'll say yes. It is. It checks the equation. This function replaced in here accordingly will give us 0, so that means that this isn't a solution of the equation, the differential equation that was given to us.